Question 9 gives me the function minus 2 plus ln 4x squared minus 1. Part A asks me for the largest possible domain. And I need to be aware here that in order to take the log of a number, this number in here has to be positive. I can't take the log of 0, I can't take the log of anything negative. So I set up 4x squared minus 1 has to be greater than 0. And that's going to lead me to the solution that, well, that x has to be bigger than a half or less than negative a half. So there's my domain, the largest possible domain for that function. And that leads me then to help me with the sketch. I've got my calculator, but I can see then that the x is a half and x is minus half is the asymptote. So I need that to be seen clearly in there. And getting these intercepts off your calculator as a calculator job. So there's my sketch. Part C, prove that that is an even function. We need to remember the definition of an even function is that the f of minus x is equal to the original function. So let's set that up. F of minus x, I replace x with a minus x. I need to show that, so I've got to put in the steps, show that that's equal to this, which is the original function as required. So there's the even function. Explain why the inverse function doesn't exist. So something appropriate here, you can talk about failing the horizontal line test, because a horizontal line will cut this graph twice, or you could say that the function is not one-to-one. So something appropriate for the inverse function not to exist there. E, piece of algebra, asks us to find the inverse. So it's now, notice that in the question here, it's restricted the domain to be 0.5 onwards, so that now we're only treating this as the function, so it now becomes one-to-one. So this inverse function will exist now with the new domain. Start off with y equals and then rearrange it to say x. So the thing to be aware of in here, of course, is that as the inverse of a log is e to the. So in that state, I've got 4x squared minus 1 will be e to the y plus 2. So that follows through to give you the algebra. You asked for the inverse function, so you must make sure that you write the answer in the appropriate notation. Inverse function equals. You're also asked for the domain. Well, I can see in here that I can put any x value. In here, e to the x plus 2 is defined for all x values. I can also get that, of course, by realising that the domain of the inverse is equal to the range of the original. And the range of this one here is all real numbers. So there's a couple of ways in which you can argue that the domain is all real numbers. F, find the derivative of g. Let's come back up to where I can see g. I've got the minus 2 will differentiate away to 0. I'm left to differentiate the log function, the log term in here. So derivative of the bracket over the original bracket, that gives me the derivative. Then on to g, two parts to g. First of all, show that g dashed x is 0, does not have a solution, so let's look for them. G dashed x is 0, requires 8x to be 0, which requires x to be 0, but that's not in the domain. So you have to realise, yes, you get a number out of the algebra, but it's not in the domain of this new function. So therefore, no solution. The last part asks us for the derivative of the inverse. So I've got to go to my half bracket 1 plus e to the x to the half and and differentiate that. So that's going to be, where are we? It's going to be the half from there times the power of the bracket times the half times the derivative of the bracket e to the x plus 2 times the same bracket again but to 1 less power. So that would be 1 plus e to the x plus 2. 1 less power would be minus a half, so actually I want a half on that bracket there. Asks me to show there are no results for it to be 0, so put it to 0. What do I need? For a fraction to be 0, I need the top to be 0. Well, this is not true in this case. e to the x is always positive than 0, so there are no solutions.